Now, relations may be described in three different ways. First of all, it can be described by a list of ordered pairs. A list of ordered pairs, which means that only for those pairs the relation is true. The second way of giving that is by using a graph. And when they give you a graph, little arrows and things will indicate where this graph is accepted and not accepted. The third way is by a rule. And when I have a rule that explains to us what the relation is about, we always have to say in which number intervals is this rule applicable. Okay, so I'm going to explain to you those intervals in terms of x and y, and then we will make it applicable to all other values. Now, if I have on a graph or in a rule, if I have an x and a y, or x and y values, I have the following. I have a domain, DO, domain, and I have a range. So the domain tells me where all my x values, and range is where all my y values is applicable. Now, how I remember is the range has got this G with, it's got this funny tail, and so does y. So range y, and that's how I remember which one is domain and which one is range. So when I have a rule, so let's say a relation looks like that, and it doesn't always look as complicated as this, but a relation can be given in the following form. They can say that, I'm going to look over here, they're going to say this set of mine where x and y are variables, the rule is y equals 2x, where x is an element of, and they give me the values. X is an element of 1, 2, 3, and that's how the thing looks like. Now that looks very complicated, but it's not. We will say that this set of values, so this indicates the set of values, where my variables are x and y, such that, so that means such that y equals 2 times x. So that will give us the relations between these two variables. But this only counts where x is an element of 1, 2, and 3. So immediately you should think, right? If x is only 1, 2, and 3, then this is discrete values. It's not continuous because it's only 1, 2, and 3. So if I draw a graph, it's going to be points. It's not going to be a line. Okay. What I can get out of this is the following. I can say that my domain is all my x values. So my domain, so I'm going to say domain. My domain is x equals, what is x? X equals 1, 2, and 3. That's my domain. What is my range? Well, my range is my y values, and they are elements of. So if x is 1, if I substitute 1 in there, then y is 2. When I substitute 2 in there, 2 times 2 is 4. If I substitute 3 in there, it is 6. Oh, what's wrong with that bracket? Cursive bracket. So my domain for this is x is 1, 2, 3, and the range is y equals 1, 2, 4, 6. So the domain is where do I find any of my x values. My range is where do I find my y values. If they give us something like, they say the element where your variable is x and y, such that the relation is y equals x cubed, and that's all they give us. They don't give us a domain, and they should give us a domain. So whenever you have a rule, you should have a domain, which means they should tell you where your x values are. If they don't tell us, we can assume it is implied. Everybody knows that x is an element of all the real values. So which means it's a solid line that goes in forever. Okay, or not forever, but yeah, that's x's element for all real values. Now I said at the start of this that I'm going to tell you then if it's x and y, we know that, and I can quickly recap that, might be helpful, that we always have our y and our x, and we say that this is your independent and this is your dependent values. So more generally, my domain, because it's my x values, is your domain is always your independent and your range is always your dependent values. But most of the time we will think of x and y, not dependent and independent. Okay. To indicate these domain and ranges, we will use the interval notation to use this. So to indicate the domain and range, you can indicate it like this when it is values. But if it's real values, we will use the interval notation. And if you don't get all of this, please look at work example 5 and after that ask your teacher.